Good morning, class. Last time we discussed transpose of a matrix and its properties. Today we will discuss symmetric and non-symmetric matrices. So let's take up symmetric matrices. A square matrix A is said to be a symmetric matrix if transpose of A is equal to A. For example, in this matrix A, if I compute the transpose, this first row will become the first column, second row will become the second column, and third row will become the third column. So you can see that the transpose of the matrix A is equal to the matrix A. So here we say that A is a symmetric matrix. Now in this matrix, 1, 2, 5, these are the diagonal elements. Now this element A1, 2 is same as A21. Similarly, this element A1, 3 is same as A31. Here A2, 3 is same as A32. So in a symmetric matrix, Aij is equal to Aj for all I and j. Next we have skew-symmetric matrix. A square matrix A is said to be a skew-symmetric matrix if transpose of A is equal to negative of A. For example, consider this matrix A of order 3 by 3 with entries as shown here. If I compute the transpose of this matrix, this first row will become the first column, second row is the second column, and third row is the third column. And if I compute negative of A, I get the matrix 0, 1, minus 2, minus 1, 0, 3 and 2, minus 3, 0. And you can see that transpose of A and negative of A, they both are equal. So we say that A is a skew-symmetric matrix. Okay, just now we have seen that this A is a skew-symmetric matrix. Now look here. These are the diagonal elements. Now here in this matrix, A12 is minus 1 and A21 is 1. So A12 is equal to negative of A21. Similarly, A13 is 2 and A31 is minus 2. So A13 is equal to negative of A31. A23 is equal to minus 3 and A32 is equal to 3. So A23 is equal to negative of A32. So thus in a skew-symmetric matrix, Aij is equal to negative of Aj for all I and j. Now in particular, when j is equal to I, we will get Aii is equal to negative of Aii, which will give you twice of Aii is 0. That means Aii is 0 for all I. And this means that A11 is 0, A22 is 0, A33 is 0. And these are the diagonal elements of a square matrix. So remember this, in a skew-symmetric matrix, all the diagonal elements must be equal to 0. Now the question is there a matrix which is both symmetric and skew-symmetric? Let's find out. Let A be a matrix which is both symmetric and skew-symmetric. Now as A is given to be symmetric, so by definition transpose of A should be equal to A. Also, A is given to be skew-symmetric. So again, by definition of skew-symmetric matrix, transpose of A should be equal to negative of A. So from these two equations, we have A is equal to negative of A, which implies that A plus A is equal to O, and here O stands for the null matrix. And this will give you A is equal to O, which means that a matrix which is both symmetric and skew-symmetric is a null matrix. So here we have a null matrix of order 2 by 2. So this is a matrix which is both symmetric and skew-symmetric. Similarly, it is a null matrix of order 3 by 3. So this matrix will be both symmetric and skew-symmetric. You can try these questions.